Example 5, we're going to do a projection again. This time, though, the direction is going to be opposite of v. So as you look at this picture, we want to have the projection of u onto v. So we do want to take this and transpose it onto this vector. But as we see, since this is past 90 degrees, if we transpose it on, it would be laying on the vector going backwards. So let's see what happens here. Now remember our formula from earlier. It was that if we want to project u onto v, so u is on top of v, then what happens is you say u dot v over basically the hypotenuse of v squared times v. That was our formula. And so let's do the math here. U dot v is going to be 4, 2 dotted with -3, 5. So I go x times x, which is -12. I'm going to have y times y, which is 10. And I combine those values. So 10 and -12, that would add up to be -2. Now I go over the magnitude of v. So let's discover what the magnitude of v is. Rather, the magnitude of v squared. So it's just basically what is h squared. Well, you take your x value, and we're going to square it, which is -3 squared. And we'll add it to the y squared. This will give us h squared. So here, -3 times -3 is 9, and 5 times 5 is 25. We add those together, we get 34. And we don't have to take the square root because we're wanting h squared. So we just discovered this fraction right here, this u dot v, all over, let me put that on here, all over the magnitude of v squared. We just discovered that is -2 over 34. Which is equal to -1 over 17 when we reduce. So we're going to take that and we'll multiply it times v. So let's now over here and have -1 over 17. And we're going to distribute that through the vector v, which again, the vector v was -3, 5. I'm going to distribute this through. We're going to get some awkward numbers that are not very common to math, but nevertheless, it's the same. It's going to be the correct answer. The projection of u onto v is going to equal -1 times -3 is +3, so we have 3 over 17, and then -5 over 17. Let's look at our picture. That would say this projection, they extended it even too far here. It should go to the right 3/17, which this is past 3/17, so it would be somewhere in here, and then down -5/17. So it would actually be a point right in there if they had drawn this correctly. That would give us a right angle. So this right here is not a right angle. If you don't believe me, I could show you real quick. I could pull out Protractor. According to their drawing, they did mess this up. I would have to line this equally. And I want to pause it just for the sake of time. And now as you look at this protractor, as I take this on, it should be a 90-degree angle if the picture is right. And you see it's actually a 99 or maybe a 100-degree angle. That's actually what it is. I know it keeps referring back to a 57, but it's actually a 100-degree angle or so. So this picture is a little bit off. The point should be right over here. But here's our projection answer. Now it said write u as the sum of two vectors. Basically what it means is write it as the sum of W2 plus W1. Well, this is W1 right here. That is what is W1. And so if you remember from example 4, to do so we would say that u equals W1 plus W2. We know what u is. U is the vector 4, 2. And we know what W1 is now, 3 over 17, comma, -5 over 17. And so this would be our algebraic expression here. And to solve, we would just subtract this over. So if we subtracted it over, we would find out that if you subtract 3 from 17 here, well, you have to get a common denominator. And so but what I'm going to do is I'll write it as a proper fraction. So I'll say this is 3 over it's not 3, I'm sorry, 3 and 14 over 17, comma, and this would be, when we subtract this over, this one becomes positive, so it would actually be 2 and 5/17. that would be equal to W2. When I subtracted these over, this would become a negative, this would become a positive. That's why I added this one and subtracted from this one. And now, so we could write our answer. U would equal W1, which we already found, which is 3/17, comma, -5/17, and then plus W2, which we just found here. You could write it this way, or if you did not want to write it as a proper fraction, if you want to do it improper, you just multiply 3 times 17, which is 51, add that, so we'd have 65 over 17, comma, and then here 2 times 17 is 34, add the 5, so it'd be 39 over 17. This is U as the sum of two orthogonal vectors. Orthogonal, again, just means that these are perpendicular or they form a right angle. Now here's one for you to try.